So let's take a look at the contents for today. We're going to take a look at the principles of the operations of these cameras, then take a look at the security end of it, and the last bit will be the thermography part of today's training. That is through some of the handheld devices that basically going to check on the different thermal temperatures of different places, either human beings or some other electrical equipment that needs to be monitored. So we'll begin. So with this technique principle for the thermal cameras, so here we're told that all objects that includes ice, flames, human bodies, and even extremely cold deep space of the universe can radiate infrared electromagnetic waves as long as their temperatures is higher than the absolute zero, that is roughly negative 273.5 degrees Celsius or centigrade. So the energy of the heat radiation of an object is related to the temperature of an object, and an object with higher temperature emits thermal radiation with more energy, and vice versa. So these are just some few images of that thermal radiation generated by the different scenes, for example, human beings and some other cold areas alongside some industrial buildings where we have some thermal, maybe some products or machines generating a lot of heat. So through the thermal principle of the cameras, this is what they're going to generate for you to get to see at your display screens. So we have different levels of the infrared. We have the ultraviolet, we have the visible light, and we have the infrared. That's for the general levels of temperatures. So in this case, the cameras, the thermal cameras work because all objects, either organic or inorganic, will at some point emit certain amount of infrared radiation as a function of their temperatures. So like all cameras, the thermal collects electromagnetic radiations, which is formed into an image, and the conventional cameras work in the range of visible light. In other words, the radiation with short wavelengths are going to be visible by the normal lenses. So the thermal cameras, on the other hand, detect radiation with mid-length or long wavelengths, which is called the infrared radiation. So these are just some principles in regards to some thermal cameras. So the cameras have two lenses. We have the normal lens and the thermal lens. Just for those cameras that have two lenses, but we have some cameras purely for thermal imaging only. So for example, this is what we have as a targeted area. This is the lens of this particular product. And again, we have the infrared detectors within the camera itself. So we have the processors or the brains of the product itself. And the signals are basically going to be processed by this signal processing circuit and the image processing chips. So these two are the most comprehensive and more high-performing signal processing devices are basically going to ensure that you get the images as the camera can produce. Maybe the camera is designed to output for you. So this is just a normal targeted area. This particular end, again, the end result will be of this format. So it's going to produce a thermal image of the real scenario, or maybe the real scene, which is monitored by the camera. So in this case, we have this thermal camera, which is an uncontact detection device that detects infrared energy and converts it into electrical signals, and then generates the thermal images and temperature values on the display. So any kind of a thermal camera will consist of a spatial lens, an infrared detector, a signal processing circuit, an image processing chip, etc. So in this case, these are basically going to be used to enhance the performance of the product itself. And again, do a lot of image optimization just to ensure that you have the real output captured by the same product. So here we have some thermal product family. We have a wide range of these thermal products. And again, they're going to be categorized based on their capabilities, maybe based on their performances. And these performances will be based on the different sections they can be installed and the distance to which they can detect those thermal radiations. So at the bottom here, we have the light series, we have the Pro series, we have the ultra lights, the ultra series. And within the three categories, they are going to be subdivided again to more other subcategories. Say, for example, you have the security and the thermal thermography. That is, these are basically for monitoring the perimeters and some other long distance surveillance. Say, for example, harbors, coastlines, or borders. So we have the different products with different categories, from the light series, the Pro series, and the Ultra series. So we have different product ranges for different application scenarios. So we'll take a look at more of these when it comes to the next windows. So let's take a look at the security end of it. Then we'll take a look at the thermography, the end. So we'll start by the different categories of these products. So since we're highlighting these products, let's take a look at some of its features. So we have this particular end, we have the Ultra series, that's the 9 series. You can take a look. The thermal PC, this for panning and tilting. Then we have 9 here to show that that is basically a 9 series. Then we have the 8 series. You can see them by this 8, the beginning value. That's the 8 series with different shapes, different appearances, with the different performing lenses, either the normal lens or the thermal lens. Then we have the mini series. So in this range, in this category, for all these product series, we have different distances that each and every product will achieve to give you the thermal imaging. For example, from the small mid-range, it will cover distances of up to 350 meters long. For the mid-range, that's for the small mid-range. Then we have the mid-range that covers distance of up to 1 kilometer or 1,000 meters. We have the mid-long range and the long range. Again, this will cover distances of up to 2 kilometers or 2,000 meters from where the camera is to the targeted object. So examples of border and coastlines, we have 3 lines of defense. So in this case, these cameras are basically preferable in this situation just to ensure that it can govern cases of, let's say, for example, immigration. Can take a look at people who are trying to cross the borders, whether day or night. And again, we have places such as so starting with this, we have the long borderline. That's that's basically some huge costs. So trying to compare the traditional kinds of surveillance with the current technologies. So the traditional way for border security is usually a fence, a high fence, just to protect the people from crossing to the other sections of the border, for example, between the countries. So you have a long borderline, which is basically going to, the costs are basically going to be high and can be easily destroyed. Individuals can come with some devices and cut off, let's say, for example, the fences, or maybe just dig the trenches to cross to the other side of um, the other sides of the land. So these are basically some of the challenges which are posed by using these other traditional ways of ensuring that the security within the different borders. We have intermittent, whereby this is not that 7 days, 24 hours a week security guaranteed. So in this case, there's a human patrol which cannot work for this number of days, this number of hours, and the view field is limited. So many may miss the target. So implying that the intruders can actually wait till the time that you've crossed a certain section, and they can even monitor the routine checks for these security guards. So if they're not within the vicinity, these guys can cross over to these border walls. So places such as coastlines, without light condition, visible cameras cannot work at night, and heavy fog at the seaside affect the visibility performance of the cameras. So high salinity environment makes devices easy to be rusted. So most of these products, the traditional products are mounted in these regions, actually are not corrosion free. So implies that the products easily get corroded because of the weather environment created by the salinity within these scenes. So in that regard, you find that those cameras needs to be replaced every now and then, which is a little bit costly and time consuming. As a result, during the maintenances, a lot of things may be missed in terms of the surveillance. Then we have other challenge is basically no intelligence, and again, slow response. So lack of intelligent features make low efficiency of surveillance because the people who are within the control center will actually be relying on the communication based on the security guards within the different sections of the perimeter walls. So by the time they communicate the security guards, time will have gone. And by the time again the surveillance NDA respond to those issues raised by the security guards, we find that it will be a little bit late. So some of the values that we can achieve by ensuring that we use these high-end thermal cameras for these scenarios are as follows. We have the ultra-long range cover. So in this case, there are devices we can cover up to 8 kilometers for human detection and 20 kilometers for vehicle detection. So comparing the size of humans and vehicles, the vehicles are a little bit bigger, which can be identified or maybe detected over long distances compared to the human detection. So alongside that, we have all time. So the thermal imaging provides a 24 hours, 7 days a week protection, either day or night, compared with the intermittent security. Realize this gives you value for having the cameras at different sections. So there is adaptability to different complex environments. So these thermal cameras can withstand harsh environment for real-time monitoring. There's less maintenance during service time. So in this case, most of these products, they can withstand corrosion. So implying that if they are within these environments where we have high salinity within the environment or within that particular area, they're going to withstand the environment. And again, the products will not end up being corroded that easily. So alongside that, there's intelligent analysis that reduces a lot of labor cost. And in this case, there's timely detection of intruders and trigger alarms in real time, compared to the traditional one whereby the people, the surveillance will be relying on the information from the security guards on the ground. So in this case, these particular products will actually be giving you those real-time information based on the triggers that they have identified and what has been captured. So information will be relayed to the security centers with a lot of details within the shortest time possible for early response. So these are some of the views that you're going to have by the use of these specific thermal cameras. So find that now, let's say, for example, this is a human being. This human being can be detected as this particular range, let's say, for example, 8 kilometers away from where the individuals are. So in this case, you can set some rules, let's say, for example, the intrusion rules or the tripwire rules based on the IVS technologies, just to ensure that the cameras can detect those violations and immediately send those notifications to the surveillance center. So during the night, let's say, for example, based on the different environmental conditions, the thermal cameras can penetrate through these environments and actually give you the right images in the event the weathers are not that friendly. So here we have some flagship models for thermal product. That's the cool with the cooled sensors. So this is how it's actually going to look like. So we have the visible part, then we have the DLC coating. This DLC coating just protects the thermal lens in the inside. So we have the imaging part inside the product itself. Then we have the anti-corrosion material. So this implies that this can survive in places where we have, let's say, for example, the sea lines. So with this kind of product, it can give you different features in terms of the distance to which can detect different objects, either human or the vehicles. So in this case, can spot vehicles and boats up to 20 kilometers and human size target up to 8 kilometers, that is with fine details. So through some of the IVS rules, for example, the tripwire and the intrusions, the product itself can detect the intrusion of human, vehicles and boats and generate an alarm to the control center for timely response. So on the laser finder, we have it here. This is where we have it. So can obtain the target distance quickly, quickly arrange personnel to deal with the field situation. So in this case, can detect items with far distances, then alerts different personnel to go to that particular place to assess the situation of the area. So apart from that, the product can give you two pictures in one screen. So it can produce two images at the same time, more for effective information, just to relay those effective information. So I find that there's some that give you the normal viewing through the normal lens, and again we have a different view from the thermal lens of this other end again. So more highlights on this, we have them here at the top. So the flagship models that's produced for better usage. We have extra sensitivity sensor, present sharper images. And this is the kind of image you're going to get because of those extra sensitive sensors that provides high resolution and again, keen, well detailed information. So alongside that, there's a higher thermal imaging quality with the defog. So implying that through the foggy environment, those particular rays from the cameras can penetrate through that environment and give you those clear images. So here at all, thermal imaging has a strong ability to penetrate the fog, even in foggy days, can still maintain clear images. Then we have one key to synchronize two images at the same time. Alongside that, there's one click to focus on the interested area or the region of interest. So this is done at the camera's interface. That's the web interface. So on the adoption for the extreme environments, we have different products which can cater for such environments. If you take a look at this product, the thermal PC PTD 8641 has the following features in terms of resolutions. In terms of the lens sizes, we have the thermal lens 2200 millimeters. Visible lens has, let's say, for example, 6 to 366 millimeters in terms of size. We have the visible lens to support IS and optical defog. Other features for this product is that it has a high pan and tilt unit speed of 0.1 degrees to 60 degrees per second. So then again, this supports multiple AI functions such as the human vehicle and boat detection. So in this case, due to its spherical design, there is low wind resistance and a stable imaging. So spherical structure design that enables the camera to break that wind resistance, and again suitable for seaside, mountains, grassland, and other large wind scenes where we have a lot of wind the environment. So in this kind of hardware design for extreme environments can produce that wide temperature range, provides that anti-corrosion ability because of the material used to create the product itself. And again, the smart wiper, so built-in rain sensor. Once detects rain leakage, linkage that is, wipe open automatically and ensure that it's clear. So in this case, it's not affected by dripping water because of that smart wiper. So products for distance surveillance, we have a product such as a thermal PC, pan and tilt, that's a PT 8641C. So this has a different resolution, a higher resolution, but you can take a look at the image first. We have the laser illuminator, we have the visible lens, we have the thermal lens. This is just the body just to ensure that you can pan and tilt accurately. Then there's electronic compass. That's using the gyro sensor just to ensure that it can capture the differences, different parts with a lot of precision. So for the anti-fog, optical defog that is presents high quality image in foggy days. So this is a scenario where, for example, you have the optical defog off, meaning that you cannot penetrate through the foggy environment to see the other items at the end. But anytime that you, let's say, for example, turn on the optical defog, you find that you can penetrate through the foggy environment and get to see the items the other side. So alongside that, we have this the thermal image. So this is just for the usual lens, and then this we have for the thermal image. So this the thermal imaging tends to be more clear and precise compared to the other lens. So then again, the product has a continuous zoom lens for long distance coverage. You can take a look from this image here. So you can see for long distances, you can zoom in the content for you to get to see clearer details. Apart from that, this is for the visible visible image. Okay, so we have the 3 kilometers laser illumination for this part here, the laser illuminator, and getting details even at dark night. So when the laser is off, compared to when the laser is on this other end again. So you can take a look at the image. This is the scene where we're trying to capture. So the laser, what it does, basically illuminates that region of interest clearly to be seen during the night. So this product can cover distance of up to 2 kilometers for vehicle detection, but can even find suspicious targets from far distance in a timely manner. So there's flexible human and vehicle detection function that make daily monitoring easier and improved work efficiency for the product. So let's take a look at the naming rule for this particular product. Dissect the model number to get to understand what each and every of these model numbers imply. So let's say, for example, for this particular camera here, we have TPC PT 8641C. So in this case, this is a thermal camera. This is for pan and tilt. Then you have, this is a 8 series. Then we have the first part here, that's the thermal effective pixels, which can vary depending on the type of product that you have. Apart from that, we have the visual resolution. So this is the thermal for thermal resolution. Then this is for the visual resolution, the thermal lens with the normal lens. Then we have this part here, C, that's for should imply that's a hybrid PTZ with laser. There's some which are basically going to imply that's basically, for example, a pentabrid PTZ 80C. So this other model values, yes, basically just going to describe the different types of lenses. For the thermal lens, this can be a motorized lens with different sizes in terms of its apertures, from 150, maybe 20 to 100, 30 to 150, 38 to 190, 80. Okay. So then again, this other end here detect the visual lens. This is for the thermal lens. This other is for the visual lens. This, for example, Z56. Then we have LE, that is a L3. That's a laser illumination for up to 3 kilometers apart. So most of these products will, for the clients, will be seeing this model up to this particular point. So the rest are basically for internal use. So in our case here, let's focus on this particular up to this point here. So other products for full intelligence are as follows. For example, we have the thermal PC for pan and tilting, 8 series 641D. So that's the model value for this particular product. So this has this, for example, we have some other key information here. For example, the heat. We have the smart wipe just for detecting raining environments. We have lightning protection. We have optical fogging. So in this case, this kind of product has to call the optical stabilization. When, let's say, for example, you have zoomed in the content inwards, what will happen before you have the image displayed out your screen at the end result after zooming, you find that there's some images which are a little bit shaky, but there's some which are basically stable. So we have those optical stabilization, whereby it can be enabled or disabled. And these are the differences between the two when the feature is enabled or disabled. Take a look at this. So this is where when the feature is enabled, and this is when the feature is disabled. So this tends to look as if the image is vibrating a lot. It's not that stable when viewing those particular regions of interest clearly. There's something here that is for SmartWeb, just to illustrate how that product works. Detect some, let's say, raindrops. Then you can see we have this wipe here, wiping out the water from the screen, shielding the lens just for better visibility. So we have more that's basically going to give you more powerful performance in terms of the thermal visibility and the visible lens. So the highlights for these particular products is that has high precision coding panel field unit, supports online temperature measurement, gives you 3D visual direct pickup of events. It's basically suitable for mobile applications whereby you can move it from one point to another point just to ensure that you can get to see events which are basically going to be temporarily put into a different place. So for example, a day, let's say 1 day surveillance or 2 days or 3 days surveillance. So this will offer you high precision pan tilt. You need to keep the presets accurate. So presets are basically those default section that you set to the camera that in the event a certain item is triggered, it can move to those sections. For example, you can have like 5 preset areas, let's say from left, center, and right again. So anytime you have any kind of movement, it quickly go to those preset sections. So you decide, let's say, for example, you just tamper with it a little bit, it will automatically go back to the section that you had preset. So that point there, that's where you had preset the camera just to focus on. So let's take a look at online real-time temperature measurement for these particulars. So in this, we'll offer you accurate, flexible, and smart protection in terms of the measuring ends for that particular product. So apart from the accuracy, can give you, let's say, for example, 2 temperature ranges, let's say from -20 degrees Celsius to temperatures as high as 150 degrees centigrade. So the temperatures can go higher than 500 degrees centigrade. So this can survive in those environments. So in this case, in terms of flexibility, we have the 5 temperature rules. We have the point, we have lines, we have rectangles, we have ellipses. Again, we have the polygons. These are basically some of those views you're going to get when it comes to those kind of measurements. So when it comes to smart, we have 4 alarm strategies. There's global, hot, and cold. There's a threshold. Alarms, we have the slope alarms, comparisons alarms. So these are basically some of those preset functions for these thermal cameras. So in this case, where we have an all-in-one solution, and basically they're easy to deploy. So instead of having multiple cameras that are going to serve different functions, let's say, for example, panning and tilting, lens, again, giving you different angles of view, having multiple cameras that are strategically put in different sections so that you can cover a certain wide angle. And again, a camera that will have, or maybe will be required for you to configure, maybe connect to an external source of maybe a speaker or a siren. And again, to have cameras connected to different illuminations, gadgets or objects. You can have all those particular elements put into one particular camera just to ensure that it can give you that easier way to deploy, and again, easier configuration in one particular device. So you can take a look at this. This has a speed dome with it. We have a rotatable thermal camera, and again, we have high-speed, high-powered speaker, this particular end again. So this thermal camera, then again, we have this, the normal lens for this PTZ here. So we can have a combination of all these separate products into one solution, just to ensure that it can be easier to manage this product that we have here. So one camera to replace a bunch of products, for example, can replace this single product, can replace the PTZ, the speed dome that is, can replace some other general and thermal cameras, and again can replace, let's say, for example, a speaker separately connected to the camera, and some other illuminated products to act as a secondary source of illumination. So in this case, one product will be in a position to serve all those functions in one place. So we have this, just keeping away the whole situation. There's this thermal that detects suspicious behavior in multiple points, not missed in any blind spot area. Auto tracking again because of this speed dome. We have active deterrents. It has a speaker here just to project those customized voice alarms up to a distance beyond 200 meters. And again, it has a strobe light just to make it eye-catching to the intruders. Alongside that, we have the dual light fusion that's equipped with the IR illuminator with a white light LED. And the white light can be used for illumination. It can be customized just for purposes of illumination in terms of places where we have dark environment. Can take a look at this different functions for this all-in-one solution. So this is basically auto tracking. This is rule set, for example, the IVS rules. Again, this has already validated the rule. Then the PTZ, I mean the speed dome, will do auto tracking for that. So supports recognition of humans and vehicles through the smart motion detections, etc. Sorry for that. So special high-end project, we can work with the Speed Dome 8 series product. So we have the air illuminators, we have the visible lens, we have the thermal lens, we have the rain sensor, and again we have a wipe. So these senses the rain, again we have the wipe here just to clear the visible lens. So we have, this can be used in places where we want to monitor, for example, boat detections in, for example, coastlines or harbors. We have boat. Then again, after doing that, we can, if it's during the night, we can give information about the boat information. This can be customized, just generate some few information, which is basically going to be of importance for the people doing the surveillance of those regions. apart from that, can detect heat detection and provide early warning. Let's say, for example, it already has detected there's some source of fire here and has alarmed already. Then it will actually send some notifications to the surveillance center for those guys to send someone to take a look at the situation on ground. So the smoke detection, let's say, for example, in places such as maybe in forests, just to eliminate the chances of having bushfires, it can provide those early warning detection of, let's say, for example, fires through detecting the smoke, then raising an alarm, or maybe providing feedback to the security team to go and extinguish the fire before it grows completely. So the use of the PTZ cameras can be used just to ensure that you can see different sections at different areas when it comes to monitoring. So we have, let's say, for example, the image gyrostabilization. Let's take a look at this. So that is when the image, assume that let's say, for example, the camera is placed within inside, let's say, for example, a ship or a security boat. Then there's this thermal imaging during the night or evening. Then the different application scenarios whereby these cameras can be mounted is basically places such as where we have the enforcement in different maybe coastlines or harbors. Then this can be used for search and rescues. And again, this can be used in cruisers. So in this case, can see one, we have it mounted here, and some other mounted in this different section, just for enforcement, just to ensure that we don't have those illegal, let's say, for example, illegal ships or boat, maybe, for example, fishing in different environments where they're not allowed to go shipping. So one other notable feature for this kind of product in this environment is that they have that anti-corrosion material that's suitable for ship use. So for the boat detection scenarios, it can detect, let's say, for example, boats that maybe are smuggling illegal content. It can detect, for example, boat accidents, and there's illegal fishing, there's aquaculture theft, dragging anchors, or again, collision with other substations. So the pain point, or maybe the challenges for having such products, not having those products, maybe such products in this environment, is that the video surveillance, it's manually duty, is a very maybe low efficient in terms of maybe generating reports and some other kinds of analysis. Those environments become a little bit slow and tedious because done manually. When it comes to patrol boat takes time, and again, the costs are a little bit high. So during the night, we have poor performance in complex environments during the night time. So, but having these kind of products mounted, this, let's say, for example, the surveillance security, maybe getting the information from these patrol boats, it's going to be easier for the surveillance individuals just to get data in real time, based on all these scenarios that you have here, either during the day or during the night. So advantages of having such solutions is that it can provide you a 360 degree patrol view, supports intelligent detection of those boats. For example, to support tripwire and intrusion areas. There's customized function for different scenarios. So in this case, functions such as where the camera can obtain boat information, such as the width, the height, the speed, and the distance. That can be customized to the product just to capture all those details in one place, one time again. So this is an intrusion or a tripwire that has been set, and the camera will capture all these events. The minute these are violated, what will happen is that it captured all these events and relays them to security. And during the night, again, this is what will happen. So it captures the boat information. And again, this can be customized to the product to get to see the information quite clearly. The anti-corrosion level for this particular product. So in this case, almost all these products have the anti-corrosion material. So implying that they can survive in those salinity environment. Maybe in places where you have seas or other environments, we have salty air. So for this particular product, you can see them, all of them have this AC at the end to show that this is basically an anti-corrosion product. So they have different ranges in terms of distances where they can capture the information, the scenes. So this will have up to 3 kilometer laser illumination. I mean, during the night, based on that region of interest, you're going to have the images clearly. So this supports, let's say, for example, this has 800 to 2 kilometers, 800 meters to 2 kilometers laser illumination. This will have 800 meters. This will have, it's not specified, but then again, they support such functions. We have intelligent forest prevention. So in this case, it's basically going to detect the different scenes, just protecting, let's say, for example, in scenes such as maybe wildfires or maybe smoke detections. So the thermal imaging from sources where we have, let's say, for example, from this particular drone, we find that this is what will be produced at this other end again. So some challenges is that when it comes to detection by the patrol rangers in patrol, find that's basically going to be to give you that low efficiency and again high cost of labor, because you're going to be having multiple rangers hired to manage such scenes. Patrol cars, again, they're not that much reliable. Observing from the watchtower, this can take a lot of time. We have the helicopter patrol. This is another expensive affair. Drones, then again, the drones can give you that service, but now the problem is that they have short battery life. The satellites, that is a technology that is basically efficient, but too difficult in terms of maybe costings and pricings. So this is one traditional video surveillance center. So with all these are basically can be managed by just having thermal cameras in place, long-range thermal cameras. So which are basically going to be intelligent. It's going to be producing those efficient reports. And again, they're going to be giving those clear details during the day or during the night. The event, let's say, for example, there's good weather or bad weather at the same time. So these are some of the challenges, and these are some of the values that are going to produce to have by having the thermal cameras put into place. Giving you accurate alarms, there's long distance coverage, there's strong environmental adaptability depending on the different scenes. For example, day and night, hot or cold weather, foggy days, and some other lighting conditions. So at the same time, to offer you that high efficiency in terms of auto patrolling the scenes in different places. Still on the intelligent fire prevention, we have, let's take a look at this short video here just to explain more on that. So this detects slightest instances of fire, maybe for example smoke, maybe heat that could generate fire, detect it, then do some early reporting to the surveillance centers. So it comes again on places such as the forest, again can detect smoke, then do some reporting again. So this can do smoke only, smoke only, or smoke and fire, depending on how the device has been calibrated to work with. So this is still more on the fire detection. So let's take a look at preventing accident before they occur, before they start. So we have application areas such as where we have oil, energy, oil and gas. There's chemical processing plants, explosions, explosive magazines. Then again, we have the flour mills and the fiber factories. So in this case, how they detect, how they prevent the incidences or accidents from before they occur is by basically providing you that early warning, can provide that online inspection, and again, high protection values level, that is. So in this case, it can detect where we have the gas pipe leaks, then send the data back to those engineers. Again, we have the valve leaks, we have torch stations, and again, we have, let's say, for example, the tank status. So this can give more information based on how that particular instrument or maybe those machines actually work. Then detect each and every of those triggers that they can start the incidences and report them before they even occur. So on the security protection coverage range, we have different series for this product that will give you those valuable, invaluable information. We have the 5 series, we have 1 and 2 series, and we have the mobile series. This series 1 and 2. So this is how the product looks like. Again, we have the differences in terms of the ranges. So these are for small range. We have 70 meters. We have small mid-range for up to 350 meters for, let's say, for example, this 5 series. So in this case, so this product actually going to give you those security solutions in terms of, let's say, for example, detection of movements either by the humans or the vehicle. And alongside that, violation rules, and those violations are going to be violations which have been set through the IVS rules, for example, the tripwire and the intrusion. Anytime these kind of rules have been violated by either these 2 filter targets, human and vehicles, alarms will actually be raised or maybe sent to the control centers. So, for example, this particular product here has a speaker, and that particular speaker can be used to project the audio to the rule violators. These are the end again. On the thermal cameras, they give you that perimeter technology, just a standard perimeter technology. So in this case, based on the security end again, we have products that will actually produce those alarms based on any kind of alarm trigger, and thus some of those alarms are going to be considered to be some non-essential alarms. Alarms caused, let's say, for example, by maybe animals, alarms presented or maybe caused by, for example, falling leaves and etc. So in this case, this traditional perimeter protection technology did not have a way of monitoring all those particular scenes. So, but with this intelligent visualization perimeter technology, we find that through the IVS perimeter technologies, we find that the device will be in a position to give you those accurate alarms, and those alarms are basically going to be produced by the essential alarm target filters, which are the human beings and the vehicles. So there, through again during the night, you can get to see this thermal imaging of the intruders as they try to break into different sections. So you can see the comparisons between the two old traditional way of doing the perimeter protection with the intelligent way. So we have the visual cameras where we've set some intrusion areas. And here we have the intrusion areas are based on this perimeter walls. So for the mid-range perimeter protection, you can take a look at these different types of challenges and the values that we gain from having these thermal cameras implemented at the sources where we're trying to do some surveillance. So we have the challenges such as photovoltaic power stations. One, the project cost pressure. There's anti-theft pressure, and again, high demand for intelligence. So these are some of the key challenges that that are experienced at this particular end again. So for example, places such as parking lot, we have car smashing and property stealing on common parking lots. We can't actually see or maybe know who could have done those kind of activities. So from having the technology implemented in such areas, now you'll end up now having a way of safeguarding those activity, maybe those particular properties in real time. So in this case here, we are going to have a value such as all weather perception, and that is a 24-hour, 7 days a week monitoring. Either it's rainy, maybe sunny, or maybe whichever kind of environment. Alongside that, there's a long-range detection of those particular violators. So the thermal detection range of thermal camera is it's roughly 3 to 5 times the general camera for the low cost. So in this case, again, this can give that identity camouflaging. So in this case, we have different views for those cameras. So we have the thermal cameras which can effectively detect hidden targets in dark and in the grass, and visible camera can also get detailed image for confirming the suspicious behavior. So in this case, we have two views from the two lenses, the thermal lens and the normal lens. Alongside that, we have high analysis, accurate analysis, that is through the thermal cameras. With its high sensitivity, a detector can reduce the occurrence of false alarms and which are caused by, for example, those animals, leaves, and other influences such as flashy bright lights. So more values to add on to this is that there's light and audio deterrence. That is that on-site warning, while the white light and audio are projected to the intruders. So in this case, we have on-site warning. There's a dual lens designed for the thermal and the normal lens. Then again, the mid-range protection for the violators, which again, based on the IVS filters, this will produce those reliable alarms, then a reduction of false alarms generated by these animals at this point. So when you get to, let's say, for example, these scenarios here, you can highlight a number of things. Let's say, for example, this can be placed in places where we have, for example, the solar farms. Let's say, for example, what we have here, the power stations, we have the railways, we have the borders, again, just to ensure that we can capture the details more clearly. So other intelligent applications, basically in just comparing the challenges and the values that we have. We have challenges, obviously, for example, due to high temperatures in different inspection areas in real time. Let's say, for example, the substations. So in this case, it's difficult to get to have those real-time events, and again, early warnings, just to prevent such incidences of, for example, fire. So in this case, all this can be enhanced, maybe facilitated by having thermal cameras to do, let's say, for example, early maintenance or early warnings to the events before they actually happen. So in these scenarios here, this can be corrected by having these thermal cameras here. For example, for visual temperature, it can actually provide that early warning. Fire point visualization, just to show you where that particular instances of fire could be in different situations depending on the weather patterns. Then again, we have the real-time warning alongside the costs, which can be decreased, and again, benefits increased all around the clock. So with this kind of value points here produced, maybe affected by having the thermal cameras, you can just highlight a few whereby the temperature offers that temperature visualization through its thermal imaging lens. So this can actually enable the engineers or the people at the site to be communicating well with the people there at the monitoring centers, just to show them where those faults are, and whereby on how to ensure that those can be reduced before the cases exponent. So places, maybe scenarios where this can be implemented, where we have scenarios such as photovoltaic, where we have, for example, we have the solar panels, the transformer substations, the thermal winds, thermal power. So in this case, they keep on monitoring the situations. In the event, let's say, for example, this particular point here overheats, the thermal can generate the heat imaging of this particular end, then again send some notifications to some other people to come and correct this fault. Still on monitoring, this is for mobile monitoring, whereby you can have, let's say, for example, these products move to some other places temporarily, and to help just do the surveillance of those areas for that short duration of time. So for the application scenes, we have for some scenes that are difficult to reach and need temporary monitoring, such as farms, construction sites, parking lots, warehouse, just to name a few. One can rent the thermal imaging mobile monitoring tower to meet the needs for those special scenes or special periods. So solution for that is simply by installing a retractable iron bar on the moving trolley. So in this case, you can actually move with that particular trolley that has the camera from one point to another point, just ensuring that you can capture all the events in real time. Then we have the Eureka series. So this Eureka series basically extracted from the concepts of the Archimedes. That's came up with the idea of measuring the crown while in this he was bathing, then shouted the Eureka and ran home naked because of excitement. So now the World Invention Fair is named after the Eureka concept of the Archimedes. So we'll play this much later. So in this case, this is what we have under the meaning of the logo, how it looks like, and that is describe the shape, the front face of the design of the product itself. So it uses the extra shape of the camera lens, and we have the E, the online E plus E, shape like an I, which means discovery. So in this case, provides again color derived from the thermal imaging iron red pattern. So some of the concepts which have been used just to ensure that this particular product comes into realization. So this is actually how it looks like, the front face. That's the Eureka series. All the Eureka series have this unique face for the camera just to depict or maybe to show the different values the camera can produce, maybe can provide the users. So they provide high resolution visual detection. And again, they provide, let's say, for example, 360 more flexible monitoring angle. So these are some of the mainstreams for the transactions of these particular products. So I provide this with you, take a look at them at your own time. So going back to the limitations of the old traditional perimeter technology versus the IVS perimeter protection. So again, here too, the traditional protection methods included having physical protections. This, for example, the walls or the fences. Then you have manual patrol, whereby you have someone walking from one point to another point, just ensuring the security. Then there's electric fence and other ordinary visible cameras, which again did not give you that proper visualization. So in this case, some of these challenges or pain points are basically going to be worked on or maybe corrected by having such technologies their end. So in this case, we can add more technology to what we have just to enforce more security at the different scenes. So for example, facing the complex on-site environment conditions such as rain, snow, fog, frost, sun, and sandstone, that is, the monitorings are pretty that very poor. So limited IR lighting illumination distance, again, that's another issue. Then the high rate of false alarms produced by animals, falling leaves, flashing bright lights, etc. And the inability of having detection of effective detect and identify persons who intend to disguise or hide from different patrols. So in this case, these are some of the challenges for the traditional perimeter protection. Now, so in this case, if we implement or maybe add the IVS technology to this perimeter protection, becomes more effective and in terms of deterring those particular violators. So the technology, what it will offer, it will offer us the all-weather prevention, either day or night. There's the warning light and audio alarm just to deter the individuals from passing by. the restricted areas. Alongside that, reduced false alarm rates, which are basically going to be produced by these false alarm targets, such as the animals, leaves, and other influences such as flashy bright light. Alongside that, the perimeter protection, for these technologies, which actually provide that long-range perimeter protection. So when it comes to early fire prevention expert, Dawa thermal cameras offers you these options. So take a look at this detection before spread at an early stage. There's you can visualize the heat source location, and again monitor temperature changes to prevent the fires. At the same time, provide that superlative sensitivity, high accuracy. So it's a one way of just ensuring that we can do some prevention before a certain event occurs. You take a look at this. There's a chart here just to show the different ways that you can have the problems are solved out. So the first time, flame, then again you have this molder, we have the flame, open flame temperature rises. So in this case, just having an ordinary kind of camera cannot end up giving you these particular protections. An ordinary camera, what will basically provides going to give you a visual view of already fire that has started. But with the thermal camera, what you can do is that you can prevent these scenarios by identifying those small instances of smoke, the smoke that can actually trigger or maybe show that there's going to be an instance of fire at that particular point. So for property safety, again, this is just another way of just ensuring that they can detect the smoke and cold behavior of the human beings, which is easier to cause fire and explosion, for example, in gas stations or chemical plants again. So this is one way of just to ensure that those instances are mitigated completely. So this black technology of smoking burn does the detection, can dissuade, and again can offer the forensic analysis just to ensure that one can see, get more information clearly about the violators of these particular scenes, for example, the gas stations and some other chemical plants. So to offer you those early warnings before they end up starting fire or any other kind of accident. So more on property safety. This is just a small clip here. This is for call detection. Then there is an alarm. We have still detecting on calls on different places, different scenes during times of day or night. So other cases, maybe some other success cases, basically theft behavior detection for the human beings based on the different scenarios where they are. It's easier to get to detect those features or options. So let's take a look at the thermography of some of these handheld devices and what they can provide us with. So this is a thermal camera of a different make and model. That's a handheld, H for handheld. Then you have 120. the series product number. So this has different sections. We have a section where you can put an SD card and a USB and charge indicator somewhere here. Then again, this is just for operation purposes. Just go back just to help navigate through the different settings for this particular product. Then we have a power button here just to switch on and off, and the tripod stand just in case you need to place it somewhere uninterrupted. So this is the front face. The back face of this, we have the laser pointer. We have the caution prompt that we have here. This is the lens itself, and this is the multifunction trigger. And again, we have the layered post. So let's take a look at some of the functions for this hand thermography product overview. So in this case, basically point the thermal lens to a certain section that you want to monitor, just to get to see the different faults. Let's say, for example, a motherboard of a certain product, you want to get to see, just power the product and get to see the faults or flaws. So a similar thing applies to where we have these meter gauges, just to point out where we have different malfunctions for this particular product or the environment itself, just to ensure that you can send someone to come and do some optimizations just to reduce those chances of having maybe chances of causing maybe fires or some other kind of injuries. So the product itself has different temperature thresholds, and again can provide you smart alarm linkages. On the portability and its rugged design, it is compact and rugged, built for portability and safe efficiency use in harsh environments as well. The product is a lightweight, only 350 grams, and can withstands a 2-meter drop test. So it can survive an impact of 2 meters high. So its ingress protection is not that highly protected against the dust and water. That is a 5.4. So simple temperature results. This is what you'll end up seeing at this display screen, that small display screen. To give the temperature, this is the temperature unit. This card, we're going to see the battery status of the product, the center spot, and the hot spots. Again, you can see even the cold spots, and I can give you the general temperature, spot temperatures for what has been captured that particular screen. The application scenarios where you can have this product used in, for example, we can use it for electrical fault inspections. Basically just measuring the temperature conditions within this section here. If it identifies there's some places which are basically hotter, for example, these circuit breakers, it can indicate, then provide you with some relevant information about the temperatures of that particular end, then do some corrective measures before they end up getting worse. We have, for example, mechanical equipment and machinery. And again, can measure the different temperatures for the different temperatures produced by that particular um, machinery, maybe mechanical device. Then you can do some corrective measures just to ensure that it does not, the temperatures, they don't go beyond what has been captured. This again can be used in places whereby you can monitor the building health diagnostics. So in this case, different places can be checked by this particular device just to ensure that we can monitor the environment well, just to avoid different hazards that can cause injuries, or maybe, for example, loss of property or damage of property. Again, this is for outdoor activities to measure different temperatures of different products, machines, or other different types of systems. Like, for example, this looks like a place whereby people charge their electrical motor vehicles. Yes. So this was the last piece of today's thermal temperature training, product introduction. So in future classes, are going to pick specific products, then state what the product can do and some of its product activities. So for today, we're just introducing some of these products just to get to understand them. So for the next classes, whereby you'll be introducing more products and describing their functionalities. So we're just going to request you to provide your email addresses here so that I can submit the presentation to your email addresses for your future referencing as we prepare for more other classes for the thermal products. So this is just an introduction to it. You're going to learn more on those particular products in future classes. So thank you so much for being part of this product introduction classroom for today. The event is a question you can always ask. You can drop it at the chat. Then I'm going to respond to those queries. So if everyone has dropped their email addresses there, please allow me to end the session so that we can prepare for other lessons for the day. Thank you so much for being part of this. I'm going to exit for everyone. We'll meet again next time.